All right, so on this, we're building up toward long division of polynomials, but we don't really need it yet because we're dividing by a single term. And so, we can get away with just saying, well, all of this is being divided by 2x. So I could say, well, that's 14x cubed over 2x plus 18x squared over 2x plus 7x over 2x. And then start canceling stuff. Say, well, those x's cancel. And I can cancel one of the x's there, and I can cancel a 2 there, and I can cancel a 2 there, and a single x there. And so I'm left with 7x squared for the first term, 9x for the second, and the last one is still just 7/2, but the x's are gone. So you can do that, and it's totally cool. An alternative method would be to do this. To say, well, what can I factor out of the top? Well, actually, that other method's not as good. That's not going to be the way to go. Yeah, let's not do that. Now, on this one, same thing, except now we've got two different variables, x and y, big deal. Okay, so all of that, each term is being divided by that term there. So if you want, you can write it similar to what I did on the last problem. And there are certainly some shortcut ways of doing this. Whatever. I'm just going to write it all out because I think it'll be easier to see what I'm doing. Or maybe it was easy either way for you. I don't know. Okay, so now I can start canceling stuff. 4 goes into 4 once, and in there 8 times. Okay, and then right here, 7 minus 5 is x to the second, and right there, 5 minus 2 is y to the third. Okay, what about the next fraction? I can cancel the 4s, and x to the 5th and x to the 5th, they just cancel. 5 minus 5 is 0, so that's just 1. Same thing with the y's. Cool. So that second one really trims down nicely. How about the last fraction? I can cancel a 4. Whoops, that's supposed to be 9. There we go. And then 7 minus 5, once again, is 2x squared. And then here, I've got 1 minus 2 is -1. So let's put that y to the positive, put that y to the 1 in the bottom. So y to the positive 1 in the bottom, and you don't have to put the 1 there. And that is my answer. Finito. All right, so now we've got what's called polynomial long division. Now, there are different things we could do with this. We could make it trickier, a little bit messier. We're not going to get into that, okay? But it works just like the old-fashioned long division you saw in grade school, like when you had something like 7 divided into 129. And you'd say, all right, 7 goes into 12. How many times? Once. And then those get multiplied. And you put it there. And then you subtract it. And then you brought down the next number. And then you said 7 goes into 59. How many times? 8 times. Then you multiplied 8 times 7. And you got 56. And then you subtracted. And you had a remainder of 3. And so you could have taken the number 129 sevenths from the beginning, and you could say, hey, that's equal to my quotient, 18, plus my remainder, over my divisor. And you'll find that these two guys really are equal. That's really essentially all we're going to do with this. It's not going to look quite the same, but it's certainly going to be similar. Okay, so let's give it a shot. So we're going to go x minus 2 divided into 6x squared minus 19x plus 10. Now, there is actually a reason why I did this first and wrote it out and left it on the screen, because there might very well be times when you're working on problems like this when you feel like, man, this is confusing. Just remember, it's very, very similar to what we did here. So go back to the basics. All righty, so we would say, what do I multiply the first term by to get this first term? Or how many times can I divide it in? Well, I'm going to multiply it by 6x, and then that way 6x times this gives me 6x squared minus 12x. All right, and then I subtract, of course, but I subtract away the entire thing. And I like to put in those parentheses to remind me of that. So I get 6x squared minus 6x squared is 0. Okay, just like it's supposed to be. Then I get negative 19x minus negative 12x. Well, that minus a minus becomes plus, doesn't it? So it becomes negative 19x plus 12x, which is negative 7x. So you really have to watch those subtractions on this. Okay, then we bring down the next term, of course. And then we start over. What do I multiply this by to get the first term here? I multiply it by negative 7. So I take negative 7 and I multiply it by that divisor. And I get negative 7x plus 14. And then I subtract. But I remember, I'm subtracting away both terms. The subtraction sign applies to both. So I get negative 7x minus itself, that's 0, of course. Then I get 10 minus 14, which is minus 4. Therefore, I can say that the original problem is equal to my quotient plus my remainder, it's a 4, it's hard to see, over my divisor. One nice thing about writing it in this way is that you can plug that in for y1 on your calculator, plug that in for y2, go to the table, see if they match. If they do, great, everything's perfect. And if they don't, you go look for the mistake, paying particular attention to the results of your subtractions. Okay, so that is how long division is done. Now, what about synthetic division? So I'm not going to bring up the topic for synthetic division there. I'm just going to do this same problem with synthetic division. Okay, let me pause for just a second. Okay, so to do this with synthetic division, and this is what most people prefer, you do it like this. From the original problem, I'm going to take the opposite of that number. So the opposite of negative 2 is 2. Stick them in a little box here. It's not necessary, but it's cute. And then take all of the coefficients in order. So 6, negative 19, and 10. Somebody came up with this a long time ago because they said, you know what, I can do all of the long division, but without writing out all the variables. All the variables really do is just keep things lined up. Okay, then I'm going to draw a little line down here so there's room here to write. And then I'm going to put a little line right here that if I were to extend it up further, it would split the last two numbers on the right. Okay, and notice what I get down here, because that's going to be my answer. It's going to look a lot like what you saw here, and you're going to see a lot of the stuff you saw in the long division in this process. When you get good at it, this synthetic division goes very fast. All right, so here's how it goes. The first number just goes straight down. Bam. Okay, let me redraw that. There, that looks better. Okay, now I'm going to use this 2 out here in the box. I'm going to combine them with stuff down here. Okay, And when I combine them, that's kind of a diagonal line, isn't it? Just like it takes diagonal lines to make the multiplication sign. So I'm going to multiply those. 2 times 6 is 12. Now I'm going to combine these two. Well, those two, they got a vertical line between them, just like you use a vertical line to make the addition sign. So I'm going to add them and get -7. And then multiply. Then add. And you'll notice the last thing, that's the remainder every time. And then these two guys here, they always end up being these two guys here. So how do I know what to do with them? Well, the one on the, working from right to left, the one on the right doesn't get an X. The next one, he gets an X. If there was another number there, maybe a 2, he'd get an X squared. If there was another number, he'd get an X cubed, and so on. So 6x minus 7 is my quotient with a remainder of -4. That's how synthetic division is done.